What's up guys, Shawnthebro here, and today we're going to be working on a very important episode. This episode we're going to be working on today is going over input buffers and command buffers. I guess it's part 6 or 7, but this is the advanced input buffers. So now we're going from this hard-coded key, hard-coded button, and actually we're going to be grabbing the input actions and input axes that were put into the game by us in the project settings, or changed by the player on a menu like the change controls widget, which don't worry, that'll be coming back in a future episode coming soon where we can modify that and make that work even better than it was the first time around. And we're going to take those values that we receive from these input actions and we're going to make the command list off of them. And we're even going to use it to determine direction, like forward, backward, and things like that. Now, just a note, any bugs that were persisting through the first few episodes here before we do this change are still going to be persisting. I still have to make a few changes to allow player 2 to be able to use commands and things like that, because we do have to separate them, especially if we're on a keyboard. If we're on controllers, this will actually work pretty much perfectly as is, but we will need to be able to separate the logic for player 1 and player 2 for a keyboard, and I did say that I would make it work that way, so we will make sure that it works for both. For now, and for the purpose of this video, our main goal is to make it so input actions determine our commands and our inputs in our input buffer. So first things first, let's just make sure that we can get this, make a command work. Now, to be honest, I can't remember what the commands are that I made off the top of my head, so let's go ahead and look at these. So these are the new commands. Instead of like ABC, which I still have them here by the way, I did not remove the old commands as to not confuse anyone. So I'm going to be doing a comparison of what it was to what it now is. We'll be getting into this, but let's just look at the input types right now. Ignore the hard-coded inputs. So for example, my fireball was ABE, but now it's backward, forward, light attack. Okay, so let's go ahead and see if we can trigger that. Backward, forward, light attack. Bam. There we go. You can see that, by the way, my keys for backward, forward, light attack are A, D, and G. Now, the inputs here were A, B, and E, so I would not have triggered that command was it going off just the hard-coded keys. It was actually going off my states in game. Let's get started in the code today. And yeah, we'll take a look at all the changes we made that got us here to where we are. We'll take a look at why we're using this now instead of the previous input system. And then I'll tell you guys what you can remove and what you may want to keep from the old system. Don't worry, the actual logic, like the logic that we made in the functions to check commands, is basically going to be the exact same. So this is going to be a minor overhaul. You're not going to have to do a bunch of changes. We're just going to kind of change what is being added to these arrays and these maps that we're using. So let's go to fighter template character, and before we get started, let me go ahead and say this is episode 63 of the fighting game tutorial series. So if you want to catch up, there's a ton of episodes for you to watch if you'd like. I will leave a link to the very first one, and actually to the whole playlist right here for you. That way you can get caught up and see how far we've come. But if you don't want to do that, that's okay. The most important part here is that you have the input buffer knowledge if you want to execute this episode. While we are changing a lot of it is still staying the same, especially the functions that we're working on. Okay, and let's get started. So now, in our fighter template character, this is our base character, so this will apply to all characters that we end up using. We have this E input type. So E input type is a new Enum I've made, and basically it's going to determine what direction or what type of input we've given the game. So specifically, I've added none, which is kind of just if you don't press anything. It can be relevant. It's mainly a default value, but it can be relevant if you need the player to wait or something like that. You can determine if the input type has changed for a given amount of time, like 2 seconds or 2 frames, and then just use a none instead. So it could be useful, but mainly it's a default. But forward, backward, jump, crouch, block, throw, light, medium, heavy, special, and exceptional attack. So throw for me doesn't really work because I have my heavy attack bound to my throw on the mutant character. However, if you have more attacks and, you're making a full game out of this, then your throw and your heavy attacks will probably be different. So you almost definitely have a reason for throw there. And I'm going to leave it just in case I end up filling out all the more attacks for all the characters. So nothing to be concerned about there. But the other ones are my attacks. The exceptional attack is my 3 and 4 button for player 1 and 2 respectively. So basically it's not if I've done an X attack, it's the extra button that I have to press to perform the X attack. Now if you're doing it just by doing like a double button press, then you can probably skip this. As long as both of your button presses as long as they're both in this input type, as long as they're both covered by the input type. But yeah, so all of our double or multi-button presses to perform an input or a command, and getting player 2 working on keyboard mode with commands, all that stuff will be fixed in another episode coming soon. We're going to really make this input buffer / command system work. And this is the major, most important change we can make to make it work. This will make our life very easy, and on top of it, it will make it work for both controller and keyboard very easily. Plus, we can even use it to fill out our command list, like the widget that actually shows you all the commands. We can literally read the value, check it against another value, like is this text forward or something like that, or is the enum with this value E_forward, and then we can display an image based on that. So we can automatically fill out these command lists. We don't even manually have to make it. And then if we update the command list can change automatically. So this is why this is such an important change. There's so many systems we can affect and save time on by doing this. So you can see that we have our E input type, and I've made it a blueprint type enum so we can grab it in blueprint. And now in our F command structure, right below that, well, that's where I have it. And in the F input info structure below that, I've added this enum to them. So before, what we were doing is using this T array of F strings called inputs. And this is where we were hard coding our values, like A, D, S, or something like that. And that was like, left, right, crouch. And okay, right, I can respect that. At least it worked, and it showed off the power of the input buffer. But now that we want to make it a little bit more dynamic and work in a few more circumstances without hard-coding values, we can use our enum instead. So I did not delete this from the F command. However, you absolutely could. Going forward, you probably won't need this inputs array anymore. So feel free to remove it. You can also feel free to remove it at the end of the episode, which is what I'd probably recommend, just in case there are any issues with adding the new one. You don't lose all your input buffer functionality. Okay. But go ahead and add a T array of E input types, and I called it just input types. And then same with F input info. I did not remove input name, which is really... It's not the command name. The input name really is like A, D, S. Like, it's actually the same thing. It's basically what you're pressing. This was really useful for, say, if we were using a gamepad. You could determine the name of the button you were pressing. So, like, gamepad, face button, left. You know what I mean? They have some more advanced names than just the keyboard keys. But, again, we don't necessarily care about the actual name of that. Now, this could still be useful in case you want to do some debugging. So you probably do want to keep input name just for some testing purposes. But we're not going to be using it in the logic anymore. We're going to be using this input type. Okay? So, again, just make these two changes. You can keep everything as is, like I have. I haven't removed these two lines on purpose. Well, these two variables on purpose. Just make sure you have the two new ones that we've added. Okay, and then of course we need a few functions to go along with this. So I've added an add to input map right here. Now this function, what it's doing is we're going to have a map, and we're going to map essentially an input, so maybe a key or some input action, to input type, so to the enum value that we are using. So for example, if D is the forward input, then we want to make sure that that forward input is what we're using. But we still need to know the input action mapping that corresponds to that action. It's not like we can just say, oh, input action E forward, and then automatically mean when we press that button that we're using the E forward enum. I mean, we have to relay that information to the project somehow. So we still need to know the input action that we are using, and then just basically translate that to the new enum type. So here's one function that we need. Add to input map. And I made it blueprint callable, so I can call it from blueprint. And now, just like how I did not remove the inputs in the two structures above, I also did not delete or replace this function, check input buffer for command. Again, until we're completely satisfied with our results, I don't want to go tearing up everything that we've already worked on, because what we already worked on does work. It's just not the best system going forward. So I don't want to go completely nuclear and just get rid of all the old stuff we did. So instead, I made a new function. Check input buffer for command using type. So basically, it's the same function we already made, but this is using the enums instead of the hard-coded strings. Alright, and we do need to make a map, which you probably haven't seen before if this is the first time you're coding in C++, and that's okay. But a map is basically a binding of two different variable types. So they become a pair, essentially. It's like if you were to have a key, and a key could only go to a specific type of door. It's kind of like that. You have this F string here, which is actually like our input action, or our input action mapping even from the project settings. And we have this E input type, which is actually the state that it corresponds to. So if I have, jump, whether P1 or P2, but if I have jump, and jump is W or gamepad, I forget what they call it, left thumbstick up, I believe it is. And, and those are the controls I have for jump. Well, then E input type for those controls needs to be jump. Needs to be E underscore jump. And that way we know whenever we press these controls, we're doing a jump input. So that's where if the change control widget comes in and those controls get changed, that's actually okay. As long as this knows that anytime that action binding or that action input mapping gets changed, we have to update and add it to this map and update the values that correspond to that input type enum of jump, then it will work fine. So let's make this map, and I think it'll make more sense as we start working on it. So tmap, and then you put in your two types in these little angled brackets, and then give it your name. Okay. And now at that point, we're doing pretty well for the header file here. And we can go to the .cpp file. Okay, so now let's go to our functions that we just added. You can go up to the top, but there's nothing new that you need to add. None of the structures need default values, and I don't put anything in the map by default. But if we go down to our add input to input buffer, I made a few changes. So before we were calling check input buffer for command, which is the function right below it. But again, because I didn't want to go completely nuclear and just get rid of all the things we had, I've just changed the function that's getting called when add input to input buffer gets called. So it takes in f input info and it was adding it to this input buffer array, which is good. But now let's call check input buffer for command using type. I've made it right before the check input buffer for command. Just go ahead and make this new function. You can quite literally copy check input buffer for command, paste it down below, and just change the name from ending at command and add using type at the end of it. Okay? And that's a good starting point. There's only a few changes that we need to make in this function. before we get into those changes, really quickly, let's make our add to input map function as well. This is the last function we need to make. Remember, it takes in an F string and an E input type. But if you use a map and say add, so map.add, then you can just add this mapping, this pair, and this is called specifically a key value pair, as you can see here if you read the comment. Then this will associate those two things together. So the key in this case is the input. The value is the enum. And you could actually reverse this. It honestly doesn't really matter, as long as you know which one you're going to be looking for. And in this case, I think it's easier to look for the input since the player is going to be pressing the input and then making the association with the enum. However, it is possible to do it the other way. Alright. So once you've added this, and once you've made this function, check input buffer for command using type, we can go ahead and compare the two functions. Check input buffer for command, and check input buffer for command using type. They're very, very similar. That's why I said copy paste them. But there are a few changes we need to make. First of all, anywhere where you see current command.inputs, make sure you change it to input types. We don't want to be using the old values for anything, okay? So these lines are good, but when we get into the second for loop here, command input is less than current command dot input types dot num. Make sure it says this. And then these are good. And then on this second if statement here, when we're comparing the input buffer to the current command, we have to make a few changes here. Now, if we go up to how it was originally, this is what the comparison looks like. So first of all, these were comparing strings. This statement was comparing strings. So we could use the dot compare and check if it was equal to 0, because compare returns a 0 if the strings are equal. Well, now we're returning enum values. So we need to make sure that we change the dot inputs to dot input type here. And instead of doing dot compare, we can just do equals equals current command dot input types instead of inputs again, and remove the space equals equals 0. Okay, we're not comparing strings, we're comparing enums, so we can just literally check if they're equal to each other. We still add to the sequence counter as always, and then we check if the correct sequence counter is equal to the current command dot input types dot num. Okay, and it's really that simple. You don't even have to change anything in the start command function. We just had to change everything over to work with the input types instead of the inputs array. So I know it's a little confusing having both of these, but since this is a large overhaul and it also took about 5 episodes to get all that working, I didn't want to just remove it and then people have to watch that again or lose progress. That would be infuriating. And I can definitely understand and respect that. So I figured it'd be easier, just make new functions, have them both there so you can see them both at the same time. And then once we're confident with it, we can get rid of the older functions, and that's fine. We don't want to have a bunch of clutter. So if it's in your way or if it's getting confusing, then definitely remove it. But for now, I've just done this, and it's a very simple change. It's like 3 or 4 changes in this function, and you're done. Now you're actually done with the code at this point. Well, you're done with the actual logic of the code. We do have to set up the commands for the mutant character as well. So if we go into our mutant character.cpp or whatever character you were putting your commands in before, then you can keep these inputs if you want. But this is how we were doing it before. Basically, what I did is I copied these, I pasted them in the same spot, and then I changed inputs to input types, and then just added the different value that I needed, the enum value now. So we are going to add the hard-coded enum values, and this is not the incorrect way to do it. This isn't hard-coded like a bad way. This is a good way to do it. At this point, someone's got to set up the controls they want for performing these commands. There's really no way around it because there's not necessarily a rhyme or reason to, what inputs go into a command. It's kind of all preference, and you know, it can be related to what combos you want to perform or whatever. My point is, this is basically the best way I can see us doing it. So go ahead and add all your enums for each of your input types. I'm keeping them all at 3. You can absolutely go over. You could do 2. You could even do 1. Like, we can use this to perform our light attacks and things like that. You can see all mine here. I've added them here. Just make sure you're changing the index as always so that it matches with the other ones. Okay. One quick note. There was a bug in the original system where if you had 2 of the same input next to each other, like say, you know, forward, backward, or something like that, you would actually have an issue where it would start using random commands. That will still occur if you do that here. It's something we will fix in a future input buffer episode. But I don't want to get into it now with everything else we're doing. So don't put 2 of the same command next to each other. Also note, if you have, sometimes, like you see how I have light attack like this, sometimes if you do the command quickly enough, then you can actually perform like the light attack instead of the command, and then you might perform the fireball afterward. But that's also intended. We're not blocking the logic at all from using the light attack just because we've added it to this command. So that's something else we have to cover. Won't automatically be done. So I'm just letting you know, these things, sure, they're bugs, but they're known and they're not intended to be fixed by this point. They will be fixed in a later episode. Alright, and now once you've made all your commands, make sure you build solution, and if it didn't already hot reload, compile in Unreal. Now, once you've done that, you're not far off at all. Basically, the last thing we need to do is determine if our inputs are good for us, and what I mean by that is determine if we want to use these inputs on our character. Basically, if they're related to our input action mappings, or if they're just random inputs that the player has pressed. And then we want to actually add those to the input buffer. So there's 2 things we're going to do here, two main things we're going to be doing here. In the add to input buffer P1 event that we had made prior, this will now be updated to show input type. Don't worry, we're not going to use it, but I just want to show you. If this is giving you errors, just go ahead and refresh that node. This new type should come up and you'll be okay. After we remove the old inputs, what we're doing here is we're going to update the add input to input buffer to work with the new values that we have. So before, we were getting key display name and passing it into input info, input name. But what we need to do now is use the map that we made and find the corresponding enum value and then pass that into the input buffer. I've written up a little print string thing here so you can test it. If you want to do this yourself, feel free. But here's what you need to do. Grab the map. So because the mutant character BP is a child of the mutant character class, which is a child of the fighter template character class, we have access to the map. So input to input type map. So that's the map that we made in code. And you can see it is a F string to an E input type. So that's what we want. You can drag off of this and you can type find. Now find is going to ask you for your key. It's going to find the value based on your key. So our key in this case was our string, remember? So we can use the key display name that we're pressing because the key we're pressing is our value here. So to say it less confusing, just basically grab your map, call find. Then the thing that you're going to plug in to get the results from find is going to be your key display name. Okay? And then it returns the enum value that's associated with the key. Then we drag that right into our input info input type. That's going to be now part of our add input to input buffer function. You can also check to see if it was valid or not, and that's probably a good idea, but it creates a default one, if it's not valid, and that's why we have the E_none, so it should work regardless. So let's go ahead and test this. This is basically, I'm just dragging off the find node, converting it to a name. That way I can get the name of this return value, so the name of the enum, and then I'm converting it to a string because that's what happens when you plug in a name to a print string. Okay. Now, when I press different buttons, you can see that it's printing out here. Now, for the record, it probably won't be doing this yet because we're not done with everything we need to do in the Mutant Enum BP. But what I'm saying here, the whole point of this, is that you can see how it prints out the value of what I'm doing. So you can see if I'm pressing a key that is unrecognized by the system, then it actually prints out none. So this can be useful. That none enum can be useful, but it won't crash or anything if you're pressing a value that doesn't have. If you're pressing a key that doesn't have a value mapped to it in the map. So yeah, I'll leave this print string on so you can see the buttons I'm pressing while we go throughout the rest of this episode. But now all we need to do is actually get the inputs into the. Basically make the pairings that we have. So I've made two functions. Go ahead, plus function, set up input mappings and set up input axes. So input mappings and input axes are a little bit different. Basically, just the way Unreal recognizes them are a little bit different because axes have a scale with them, whereas mappings are just pressed and released. And then at the end of begin play of your character, I call set up input mappings. So you can do that, and let's go into it and make the logic. Now, it looks like a lot of logic. It's not. I've just broken it up so that we can do every single attack this way. We're only going to ever have to do this one time, so you can write a better function that kind of loops through and does it for you, but honestly, this is perfectly fine. Alright. Now, this is going to be a little bit confusing just because of the way you have to grab these keys in Unreal, but bear with me. We're going to get input settings. Okay, in get input settings, what it does is it actually returns the, like when we go edit project settings input, it's getting this value for you. Basically getting all the data that this has. Then you can see I get action names. Remember, the action mappings are the ones that don't have scales. So all these guys right here. Jump attacks. Just not the move rights. Then we're going to for each loop and loop through all of these action names. It's going to quite literally return the name. Then, off of the get input settings, we can drag off this and do get action mapping by name. Okay? And since we're looping through the names, we can pass in the array element into the in action name. I'm going to get this out of your way. And then get action by name returns the input action key mapping structure. What that is that's the actual key with all the information about it. So it's got the name, the key that is required to press it. It's not just a key, it will work with buttons like on a gamepad and stuff too. It's just called the key. And then these are all the things like if you have to press Shift, Control, Alt, or Command with this to perform this action. So loop through the return of the get action mapping by name, and you can drag off the array element and type break. Do that and you'll get this node here. You may have to open it up. And before we go any farther, at the end of the first for each loop here on completed, basically because this is once the function is completed, I go ahead and call setup input axes. So we're going to set up all the input mappings first, for the input action mappings, and we're going to set up all the input axes next. Alright, and now the rest of this function is going to be the same logic the whole time. So you can keep copying, pasting, and just changing a few things at each one. Or, again, write a loop if you'd like. But you should only ever have to do this once. I don't think the input buffer or command system will ever have to be overhauled completely again. We may make a few changes to it here and there, but I think you're in the clear to make it however you want, and it should be good from here on out. So, this is also only going to run once, so it's okay if it's not the best, if it's not the best performance-wise. Here we go. We're going to drag off the action name. Now this is like jump P1, light attack P1, all that stuff. We're going to drag off of it and do the contains check. Now you can't really do this without converting it to a string first, because that's the specific one we want. So just do toString, and then you'll have this name to toString, and then drag off of that and do contains. String contains. Here we go. And you get this node. Now you search for the command name. Remember, the command name that we have in the input, in the project settings input, is never going to change. So this isn't a bad way to do it. This isn't like a hard-coded way to do it. If you decide to change it in the project settings, then yes, we do have to update it here. But that's okay. Like, that's to be expected. So we can assume that these are basically finalized names, and we can use them here. So you're going to search for the substring. You're going to search for the command, or excuse me, the action mapping that you want to find. So say I started with jump, like I did in this case. Then I want to search for the substring of jump. This will find both P1 and P2, although we're not going to be separating them yet. We'll be doing that in a future episode. And then we want to add these to our input map, essentially. So if this is found, we can do a branch right off of this return value. So contains returns true if it was found, and it returns false if the substring was not found. So in an action mapping where jump does not exist within the name, it will go ahead and skip it. But if jump does exist within the name, it will find it. Now you need to be as specific as necessary here. So if you have like jump and super jump, well, guess what? Super jump is also going to pop up. So if you don't want that to pop up under this, for this mapping, then you need to make sure that you specifically look for super jump in one of them. Or you can make it a more exclusive search where you're doing contains, but you're only checking for jump, and that's it, not super jump. Things like that. So just be aware of this. There are some snags that could catch you off guard if you're not ready. Okay, so that's what I've done up above here. That's what this is so far. Now the last thing we need to do is add the input to our input map. Since we know that we're searching for jump, we can flat out pick the type in this function call, in the add to input map. We don't have to do anything fancy. It's not a hack or anything. Just pick the type that we're searching for. Jump, right here. But if you still have the input in, like I do, you can continue to fill it out. So the way you do that is you drag off key, get key display name, and then you can drag it right into your input. It will automatically convert it for you. And you can see that's what it's done here. Then I made reroute nodes, which you can just reroute node and drag things into it if you're not aware. And I've brought this along to repeat this process for every action. So I'll go through it quickly. Make sure if it's true, you don't continue to set up logic for this input map. You understand? Because this is looping for every key for every action mapping. So if we already found an action mapping to bind this key to, we don't want to bind it to other action mappings. Don't worry, we'll get them all. Just, you know, we have to do it one at a time. So if it's true, stop it there. If it's false, we look at the next action mapping at the next key. So now we look for crouch, and I put the type of crouch. If that's false, we look for block, and I put the type for block. If that's false, look for throw, put the type as throw. If it's false, look for attack 1, put the type to light attack. If it's false, attack 2, medium attack. If it's false, attack 3, heavy attack. If that's false, attack 4, special attack. And if that's false, exceptional attack for type exceptional attack. Okay? So I know it's repetitive, but again, you can do a loop or whatever you want, but really, we just need to get it done. It's a one-time thing. The performance here isn't bad, and it's at least very explicit. We know exactly what we're looking for. We know exactly where an issue is going wrong if a key isn't being bound. And now we need to go to our setup input axes function. So we go in here. You're going to be happy to know that it's pretty much the same thing. There are a few changes because we have to use the scale and factor that in for whether we're moving backward and forward. Eventually, and probably honestly in the next input buffer episode, we will cover using the scale and if the character is flipped, or at least what side of the player they're on, or what side of the enemy player they're on. That way we can determine, we can reverse the command lists and things like that, which is a lot easier now because we don't have to swap out hard-coded keys, but we can swap out Enum values, which is very easy to do. But we're not into that yet, so let's just get this working as is. Input axes, here we go. Get our input settings, get our axis names, loop through them, just like we did before. Then we get our axis mapping by name and loop through them, just like we did before. Now, this is where it starts getting a little bit different. It's the same basic concept, but the input axis key mapping is a little bit different the way it's set up. So drag off of array element and break it, and you'll get the name, the scale, and the key. So we're still going to do a contains check, but we also need to do a scale check afterward. So first things first, contains, and put in your substring, just like we did all of last function. Move right is what I want. In my case, I have move right P1, move right P2, and move right controller, and that's actually okay. You'll see why that's okay in the next episode of this. But that's okay. It's alright to have multiple things with the same name given the right circumstances. It's only if you want to separate the logic, do you want to make sure that it's not picking up on multiple names. Alright. So if it's true that it found move right, then we continue. But we're not ready to apply the input map yet because we need to make sure that we're applying the right direction. So we take the scale, and I just did a greater than check on it. I did float greater than, and I checked that the scale was greater than 0. Because in my project settings, you can see the input axes, move right. My scales are only -1 and 1. The controller is a little bit different because the axis itself can be everywhere between -1 and 1, not just a solid -1 and 1, but it could be like 0.2. However, what I decided to do with it is check if it's greater than 0. Now there is again another snag here. So if you're using the controller and you check if it's greater than 0, then that'll work, but if it's on 0, then you won't be being set back to none. So we need to add an extra state here. Just be aware of that. You can do it now. Just check if this is equal to 0. Like this. And then if it is, and it's the controller, then skip this. But we have more updates we have to do for controllers anyway, so we'll cover that in that episode. Okay, so check if it's greater than 0. If it is, we know then we're moving forward. If it's not, we know we're moving backward. Remember, this is not taken into account flipping yet, or what side of the enemy player you're on. So that will further update the logic. I do the same thing here where I grab I get key display name, and then I convert it to string, and then pass it into the input here. But yeah, I pick forward and backward here, and now that means as long as I'm on the left side, this will be accurate. I will be moving forward toward the enemy or backward away from the enemy, plain and simple. And there we go, guys. That's pretty much it. So it's not too bad of an episode. I mean, there's a lot going on, but a lot of it we already had in place. We just had to update it to use a better system. That way we can further implement it and further alter it in the future without issues. Now you can see player 2 does get the correct values. Like, other than this, because he's on the flipped side, if I were to send him over here, you can see he's getting the correct values. Player 2 does work with the system, as opposed to how player 1 only worked in the original system. However, player 2 will not be able to use commands yet, at least not to my knowledge, because there's still a lot they need to do. So, for example, if this is the light attack, you can see that player 1 uses it. And there's a reason for that. And it's because we're using the add to input buffer with player 1, and player 1 is the character that we're always using. We need to divide up the inputs for player 1 and player 2 because we need to separate their command lists. And then once their command lists are separated, we can know who should use what command. And that's when we can get player 1 and player 2 using specific commands. But for now, you can see that their inputs are being tracked properly for both characters. So this is good. This is a great first step. Then once they're separated, we'll be good to go. And we'll also fix up a lot of those other bugs that we've had since the beginning along the way. But this is going to pave the way for so many future episodes and so many future mechanics. So this is a very, very important one. Anyway, guys, if this helped you make your input buffer a little bit better and you enjoy it, then please subscribe. It does more for the channel than anything else you can do. Just lets me know that I'm doing a good job and helps me continue this series. I want to give a huge shout out to my YouTube membership and Patreon supporters. Thank you guys so much for all the love and support you've given and for continuing to help me work on these and encourage me to work on these and better myself through these tutorials. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. It's in the description. You can click the link and join it. I can't put it in the iCard because YouTube is weird. Also, if you want to come hang out with us on Twitch or watch programming streams, you can either check us out twitch.tv/Shawnthebro27 or check us out right here on this channel, which is my YouTube channel, for all the streams that I do, both the gaming streams and the programming streams. We're working on a Castlevania side-scrolling game right now, and it's incredibly fun. My schedule for the programming streams is every Friday, 6 to 8 p.m. Eastern Standard Time, right here on this YouTube channel. They go live on this channel, but I archive them somewhere else. I archive the streams on the other channel just to be safe. That way we got a backup. Alright, guys. Thank you so much for all the love and support. I'm Shawnthebro. I'll see you later. Goodbye, guys.